In this video, we're going to consider the function question that you typically get in National 5. In fact, there's a couple of variations on this question, one of which is this style, evaluating a function at a value. Students tend to do that one pretty well. The other style, evaluating a value that you put into the function to get some output value, students tend to really struggle with that. It is a significantly trickier question. They're completely different in terms of how you go about them. So we want to primarily focus on this more difficult type. Let's start with an easier example. So remember, a function is just like a formula. So this function notation is really just a way of saying this formula. And this formula is just telling you to take your x value, whatever value you want it to be, multiply it by 3 and add on 2. That is the formula. That is a function. That's what it's going to do to the x value. In this case, they want us to evaluate f of minus 4. So that literally just means replacing the x with minus 4. So instead of 3x plus 2, we're going to get 3 times minus 4 plus 2. Remember, these are multiplying, so it's 3 multiplied to minus 4. And it's just an evaluate question. You're just working this out as a number. 3 times minus 4 is negative 12 plus 2. So that would give you an answer of negative 10. And remember that a function or a formula, when you put a number into it, you get a number out. So the input value here was negative 4 and the output was negative 10. And that's a really important point for the next question type. In the next question type, which would be like this guy here, they're asking us to put some number a into the function to get an output value of 24. They're calling the value we're putting into the function a just as a sort of placeholder, just to distinguish it from x. And it's that a that we're trying to find. So in this first question, we were putting a number into the function to get a number out. In this part, we know what number we're going to get out. We want to figure out what number goes in. Now, a lot of students try and do this by trial and error, and you can eventually do it by trial and error, but you're probably not going to get all the marks for that anyway. But it's not really the way to do it. The way to do it is just to think of this, right? If you're evaluating f of a, that's just like evaluating f of minus 4 or f of any other number. You're just going to put whatever's here into the function. So in the same way we replaced that x with minus 4, now we're just going to replace it with a. So that becomes 3a plus 2. But we're also told that f of a is 24. So if f of a is that, and f of a is also that, then these two things must also be equal. So essentially we can just make a little equation where 3a plus 2 is equal to 24. And that's essentially how you do these questions. You just set the number equal to the function with the value subbed in. Then it's just a little equation to solve, just like normal equations. So 3a equals 24 minus 2, which is 22, and then divide by 3 to get 22 over 3. As the final answer. This one's come out to be a sort of weird final answer. Sometimes they do, sometimes they're whole numbers, negative numbers, it could be anything. So this is telling us that if we put the number 22 over 3 into that original function, we would get the number 24 out. So essentially in these more difficult versions of function questions, you're working the question backwards. Let's take a look at this one. There's no part A, there's no evaluating. This one's just straight into the more difficult part. So again, we could say, right, if we evaluated f of t, that would literally be replacing the x with t, so 5 plus 4t. F of t is 5 plus 4t algebraically, but numerically f of t is 33, but they're both f of t, so they have to be the same thing, they have to be equal. So that is equal to that. So again, we're just making a little equation. 5 plus 4t equals 33. At that point, it's got nothing to do now with functions. It's just an equation to solve. That would give us 4t equals 33 minus 5, which is 28. And just dividing both sides by 4, just like a normal equation, to get our final answer of 7. So that tells us if we put the number 7 into that function, we would get the number 33 out. Let's just check that. That would be 5 plus 4 times 7. 4 times 7 is 28, plus 5 is 33. So essentially working these function questions backwards. You'll often see indices questions that refer to writing your answer with a positive power. So I want to quickly go through that because that kind of tells you two things. So first of all, it tells you that when you get your first version of the final answer, it should be a negative. If they're telling you to write it as a positive, it should originally be negative. And secondly, it tells you you have to take that negative power and flip it somehow into a positive, which there's a technique for. These questions, well, the positive part, flipping into a positive, tends to be quite poorly done. So let's just quickly go through that. So because this question would be worded, evaluate or simplify and write your answer with a positive power, we're looking out for a negative power in our answer. Okay, so that's the first thing. So let's just start using some of the indices rules. So there's a rule here that says you can multiply those two powers together if they're separated by a bracket. So it becomes n to the power of 8, just leaving the other term the same. Then we can use the sort of first rule of indices that says if you multiply two things, you add the powers. The 12 is just a coefficient, that's just going to stay there. The n is a power of 8, we're adding to that a negative 10. So 8 plus negative 10 is just like 8 minus 10, which is going to be a minus 2 power. So we can see that we have got a negative power, which is what we expected. If this had gone straight to like a positive 2, there's something wrong with the working. So look out for that, it's telling you it should be negative. To turn it into a positive power, you simply put it on the bottom of a fraction. So this just becomes 12 over n squared. That's how you turn it into a positive power. Chuck it on the bottom of the fraction, change it from a negative to a positive, and that's all you need to do. The sort of rule for that, if you like, is that if you've got a to the power of minus b, that's the same as 1 over a to the b. In other words, if it's negative on the top, put it on the bottom, change it to a positive power. In this video, we're going to look at quadratic equations, and in particular in the variations you get on those questions. So none of the question types in quadratic equations are in themselves particularly difficult with a bit of practice. It's the confusion between the different questions, which are very similar, that tends to cause the problem. In fact, I see students all the time confusing them, muddling them, answering the question with the wrong technique sort of thing. So there really are only 3 techniques to look out for. So one is where you're given a quadratic equation. Remember, that's an equation that's got an x squared in it. So a quadratic equation, and they ask you to solve it, but they make a reference to decimal places or significant figures. That essentially tells you it's a calculator question. That's going to be the quadratic formula, like no question about it. This one is very similar. It's a quadratic equation, and it does ask you to solve, but there's no reference to decimal places. So whilst you could use the quadratic formula for that, that's probably going to be in the non-calc paper, and it's going to ask you to do it, well, not ask you, but it's kind of suggesting to do it by factorizing. Because if you factorize, you're not going to get decimal solutions, you're going to get whole numbers. So those two are very similar, but completely different techniques. The third one's not asking you to solve the equation, but a lot of students will solve it, or they'll do something more aligned with solving than they will with actually answering the question, which would be to determine the nature of the roots. The nature of the roots, remember, means how many roots are there? 2 real roots, 1 real root, or no real roots. So in this case here, the clue is the decimal points. That tells you you're going to be using the quadratic formula. Remember, that's on the formula sheet, so you don't need to memorize it. The point of this video is not so much to go through the technique. The point is to be able to learn how to separate these out. So because I've seen decimal places, that would tell me I'm using this formula. It would also probably tell me that this doesn't factorize. If I tried to put that into 2 brackets, I would find that it's probably not going to work, because that's how the questions tend to be designed. So I would need to go here to my equation and say, right, the 2 is the a value, the 5 is the b value. Being careful with negatives here, the c is negative 4, and then I would just substitute those values in the equation, and then just go blah 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 and carry on and finish the equation. Finishing off is normally easy enough once you've decided that it's a quadratic formula. In this case, however, although I'm being asked to solve, no reference to decimal places or significant figures, that tells me I should be able to solve it by factorizing. So in this case, it's a trinomial, so we could factorize into 2 brackets. This one does factorize with a negative 8 and a negative 3, and then you could go ahead and separate that into 2 little equations like this, and then you would get the 2 solutions like this. Sometimes actually in a question like this, they will say solve algebraically, and if they say algebraically, then they mean by factorizing, not by a numerical method, which is what the quadratic formula is. So again, not too worried about the solutions or the method, more focused on how to distinguish which technique to use, no reference to decimal solutions. In the third case, we're looking for the nature of the roots. So remember, that is related to the quadratic formula, but just this part, the discriminant, the b squared minus 4ac. So as soon as you see nature, you've got to think in your mind, you've got to associate that with b squared minus 4ac. Remember, you don't need to include the square root, just a bit under the root. So again, you would go about this by identifying your a, b, and c values. So a is 2, b is 4, c is 5. Plug those into the formula. 4 squared is 16 minus 4 times a times c, which is 5. So that's 16 minus, what do we have there? 20, 40. So that's going to come out to be minus 24. Because it's come out to be negative, that would be no real roots. So the solution there would just be no real roots. If it come out to be positive, then it would be 2 real roots, and if it came out to be 0, it would be 1 real root. But again, the key there is nature. So I see a lot of students saying the nature of the roots question, and they interpret it as this, finding the roots, finding the solutions, or this question, and they interpret it as nature of the roots. The key is to not get them confused. So hopefully that will help keep those different techniques separate in your mind. In this video, I want to look at a variation on a straight line question that tends to throw a lot of students off. So the most common straight line question is when you're given 2 points on a line and you've got to work out the gradient and the equation of the line. And most students are okay with that question. A more tricky question can be if you're given the equation of the line and you're asked some questions about that line. And the things you'll be asked are, what are the gradient or the y-intercept or even the x-intercept where the line crosses the x-axis. So if the line is in the correct format, which this one is and this one's not, then you can just read off the gradient and the y-intercept because that's the m value, that's the c value. They just are the gradient and the y-intercept. So you can just read them off. There's no work to do there. So given this line here, we can just say by looking at the line that the gradient, which is the coefficient of the x term in the correct format, the gradient is just equal to 2. So a no-brainer, just reading that off. Similarly, the y-intercept is 8. Just remember that's only the y-coordinate of the y-intercept. So in general, usually you will need to include the other coordinate because they will say what is the coordinate, and the full coordinate is going to be 0, 8. Okay, so just by reading off that straight line equation, which is in the correct format, we can see that the gradient is 2 and the y-intercept is 8. But the thing that's not in the formula is the x-intercept. We need to find that. But let's just consider what we've got so far for our line. So if I was to go ahead and make a little sketch here, the y-intercept is at 8, so that's going to be positive 8, which is up there somewhere. The gradient is positive 2, so a positive 2 gradient goes sort of this way, so it's going to be something like that, meaning that the x-intercept is somewhere over here. So it's that x-intercept point we're now trying to focus on, but just like the root points on a parabola, if you're a point on the x-axis, you have got a y-coordinate of 0. So any point along the x-axis has got no height, like no vertical height, or it's nothing up the way or down the way. So this has definitely got a y-coordinate of 0. So it's a no-brainer that we can say that the y-coordinate of that point is going to be 0. So we can use that information to find the x-intercept just by substituting that 0 into the equation. So if we go back to our original equation, which is y equals 2x plus 8, substitute in the 0 for y. As soon as we do that, we've made it into essentially a little equation to solve to get the x value. So if we just solve that equation, we would get 2x equals negative 8, x equals negative 4. And you can see that sort of fits into the diagram, because if that point there was 8 up the way, that could be 4 to the left, 4 back the way. So that's how we find the x-intercept. Similarly, actually, that's how you find the y-intercept, because the y-intercept point has definitely got an x-coordinate of 0. If you put a 0 in there for x, you would get y equals 2 times 0 plus 8, which is just 8. So this is only the y-intercept purely by the fact that if you let the x be 0, it's going to take out the x term. That's why that n number is always the y-intercept. But that's in the case where the line is in the correct format. This line is not in the correct format. So let's say we're dealing with the same 3 questions, gradient, y-intercept, and x-intercept, for this particular line. Well, the x-intercept and the y-intercept work the same way, because if you're on the x-axis, your y-coordinate is 0, and if you're on the y-axis, your x-coordinate is 0. So we don't really need to adjust the formula to get those values. If we did rearrange the formula into this format, the n number would be the y-intercept. But you don't have to do that. You could do that, but you don't have to. So if we just say, for example, that if we're trying to find the y-intercept, we can just say that we're going to let the x be 0. So taking our equation, that's going to be 4 times 0 plus 3y equals 12. That's going to be just 3y equals 12, and then y equals 4. So that tells us that our y-intercept is at 0, 4. So there was no rearranging involved there. Similarly, if we wanted to get the x-intercept, we're just going to do the opposite. We're going to let the y be 0. And these are the same principles you would use for finding the y-intercept or the root points on a parabola graph. If you're the x-intercept, if you're on the x-axis, your y value is 0. So we're putting a 0 in for y this time. So that would be 4x plus 3 times 0 equals 12. So that's just going to be 4x equals 12, given x equals 3. So then we can say that our x-intercept is going to be 3, 0. What about the gradient? Well, the gradient you can't, well, one thing you could do is to use these 2 points now to get the gradient. But generally you're going to get the gradient by rearranging the line. So just by doing a bit of algebra. So we want to make y the subject of the formula. So we can achieve that by subtracting the 4x to the other side. So we're going to get minus 4x plus 12. Almost there at that point, but you need to get it all the way to y. So dividing by 3. So y equals minus 4 over 3x plus 12 divided by 3, which is 4. And then we can see that the gradient is that number there, which is minus 4 over 3. So generally for gradient, you do need to get the line in the correct format unless you've got 2 points on your line. But for the x and the y-intercept, it doesn't matter which version of the formula you use. You're just subbing in the appropriate 0. Notice, by the way, that after I rearranged that, the y-intercept came out to be 4, and we'd already found it to be 4 by this algebraic method. So all these methods should be consistent. But the key takeaway here is that if you're a point on the y-axis, your x-coordinate is definitely 0, and you can use that. And if you're a point on the x-axis, your y-coordinate is 0, and you can use that to find the other corresponding coordinate. In this video, I want to look at the graphs of quadratic functions. So this is generally considered one of the, if not the most difficult topic in National 5. It does cause a lot of confusion among students, but there's a couple of things that you can try and keep in mind that does make it significantly easier. Let me just quickly demonstrate. So if you've got a quadratic graph, then that's going to be a parabola graph, like a U-shaped graph. So those graphs can be anywhere on the xy plane. You know, they could be up here, they could be down here, they could be upside down, they can be anywhere, right? But a typical parabola graph might go something like this. And if it goes like this, then it's got a y-intercept point and it's got 2 x-intercept points, which are called the roots. But if you think about it, if you're one of these root points, what is your y-coordinate? Like, how high up are you? How low down are you? Like this point here, what's his y-coordinate? This point here, what's his y-coordinate? They're both 0, aren't they? So if you're a root point, which you can just think of as being an x-intercept, then the one thing that you definitely know is that you've got a y-coordinate equal to 0. In other words, if you're on the x-axis, your y is 0, the opposite letter is 0. Similarly, if you're this point here, the y-intercept, your x-coordinate is definitely 0, because any point on the y-axis has got an x-coordinate of 0, because it's 0 along the way. So that tells you that if you're the y-intercept, then you are guaranteed to have an x equals 0. In other words, for finding these key points, you just need to remember that it's the opposite letter that's 0. If you're on the x, your y is 0, and if you're on the y, your x is 0. And that principle is also true for the straight line graph topic. You know, if you're the y-intercept of a straight line, you've got an x-coordinate of 0. If you're the x-intercept, you've got a y-coordinate of 0. So we need to use this information if we're trying to work with the graphs of quadratic functions. So if I give you this function here, and notice, by the way, these are written in different ways. That's in completed square form, that's in factorized form, and that's one of the big challenges that students often face in quadratics is the different forms, but it doesn't matter what the form is because these principles are always true. So if we wanted to find the root points here, we would just say, okay, root points, they're the x-intercepts, let the y be 0. So I put a 0 here for y. That then gives me an equation to solve to get the x. This is a quadratic equation. You can solve it by separating into 2 mini equations like this. It's already been factorized. Then we just solve that to get a 6 and to get a minus 4, telling us that the 2 root points would be 6, 0 and minus 4, 0. Similarly, if we wanted to find the y-intercept, we just let the x's be 0. So we just go, okay, I'm just going to put zeros in the place of the 2 x variables. 0 minus 6 is negative 6, 0 plus 4 is 4. These two brackets are multiplying, so that would give you minus 24. So the y-intercept would be 0 minus 24. Okay, so just purely by using those two facts, we're able to really quickly actually find the two root points and then the y-intercept. Now in a question like this, that might be the question done, or more commonly it will ask you to plot those points and then draw in the graph, and maybe ask you for other things as well, like the turning point or the line of symmetry, but we're just focusing on the root points and the y-intercept here. So what happens in this one? Well, the same thing happens. If you want to find the y-intercept, you're going to let the x be 0, and if you want to find the x-intercept, you're going to let the y be 0. Typically, when it's written in the completed square form, they don't ask for all of those points, but let's say, for example, we wanted to find the y-intercept. So for the y-intercept, we know we're going to let the x be 0, so you would just put a 0 in here like this, and then continue the calculation, just in the same way we continued the calculation here. It's just in a slightly different format. So 0 take away 4 is negative 4 squared, like this. Negative 4 all squared is 16, minus 2 like this, and that'll come out to be 14. So that y-intercept point is 0, positive, don't know why I put a negative there, 0, and a positive 14. So don't need the positive, so 0, 14. Okay, so again, this doesn't matter about the format, we're just using this key fact. This one, by the way, remember, is optimized for giving you the turning point, because the turning point is just these two numbers with the sign changed on that one, so that becomes a positive 4 and the minus 2 stays as a negative 2. So that is just by inspection, just by reading off the numbers, that would also give you the turning point. So if you see one of these in completed square form, they are essentially giving you the turning point by writing it in that form. Usually in this question, with this form, they ask for the y-intercept and the turning point. If they were asking, though, for the root points, sometimes these don't have root points because they're just sort of floating in space like this. But if they do have root points, well, the same principle would apply. For the roots, the y equals 0, so you put a 0 there. The reason they don't often ask for this one is because in this format, it's a slightly tricky equation to solve, which would involve sort of manipulating the algebra a bit like this, and to get rid of the squared, you've got to take the square root, and it starts to wander off into territory that we don't really like, unless they give you really nice numbers. So usually they don't ask for that one. But the principle is still there. You would still just let the y be 0 and continue and solve in the same way. So if you want to get better at quadratic graphs, it is a no-brainer that you need to learn those two concepts, because it doesn't matter how they write the formula. They could even write it in a sort of trinomial format, which is the third type, I guess, something like this. And these same principles would apply to this, this, and this to get you these key points, which is going to get you most of the marks in a question like that.